The gear tooth profiles are involutes. Okay, let's try to generate one using very simple tools. So now I have a disk. I call this disk base circle. So this is the disk base circle. Okay, on top of that, I wrap a rope. Okay, this is a rope. It is currently wrapped on the base circle surface, outside of base circle, like this. Okay, so then what I'm doing now is to attach my pin to one point of this rope, and then gradually unwrap this rope away from the base circle. Okay, so I'm doing this. So my pin is supposed to draw a curve, and this curve is called the involute. Now, at current location, which basically is at any typical location, we see important things. First of all, okay, this straight line, this unwrapped rope is perpendicular to the involute that I'm just plot, okay, at this current location, which is, again, any location. And this straight line is tangent to the base circle. Third one is that from the tangent point to my pinpoint, okay, the straight line equals from this tangent point to the starting point of the involute on the surface, on the circle. All right, so this arc length equals the straight line length. Okay, so let me remove this disk and plot the things I just mentioned. Okay, so this is the involute. And this is the line of generation. Okay, and then currently, the line of generation is perpendicular to the involute we just made. This is a typical location. Basically, at any location, we have this relationship. And also, this line of generation is tangent to the base circle. Okay, if I make a radius, it has to be perpendicular to one of the radius. All right, so here, let's name this one BI. Let's call this point KI. And let's call this point K naught. Okay, so straight line length equals the arc length. All right, so, oh, yeah, I want to mark that out. Straight line length from here, all right, equals the arc length over here. So this is the unwrapping process. All right, so now let me replot this whole thing, but showing more steps over here. So basically, you see base circle, and you see BI and KI, which all start from K naught, and a particular point P and B as well. Okay, so we can summarize a number of properties of the involute. The first one, who equals whom? As I mentioned here very clearly, BI, KI equals BI, K naught. So straight line equals the arc length. Okay, this person equals that person. Okay, and also one more thing, that is the normal to the involute is tangent to the base circle. Okay, second point. And then the third point, okay, this BI has a particular name. It is the center of curvature. Okay, we use this as the center of curvature, and we use this length and plot the involute at this location. So BI, KI is the radius of curvature. And the entire process is outside of the base circle, so there's no involute inside the base circle. So 4 properties. We can have a couple more. Okay, the fifth one is that we have a base circle. We can make an involute in this side. We can also make another one the opposite direction, so opposite side. And then we can draw the common normals, okay, of these 2 opposite involutes. As currently you see this A1, B1, and A2, B2. All right. So each tangent the base circle at this one at C1, this one at C2. But they both start, each of them start at a fixed location. This one from A1, this from B1. So that means these two involutes, no matter where we are drawing this common normal, they share the same arc length, okay? A1 and B1. From that, we can easily prove that actually any common normal between two opposite involutes they have the same length, okay? So let's take C2 let's take B2 and A2, the tangent to the base circle at C2. All right, from this side, you see the straight line of generation, the arc length, so straight line equals the arc length. On the other side, okay, straight line equals the arc length over here. All right, so we add the two straight lines. What do we get? We get arc length A and B. So we can do the same thing for A1 and B1. They have to equal to the same arc length. So therefore, any of those lines, those common normals, must be the same length. Okay, very easy to prove. All right, so the other one, what this one shows is that the shape of the involute, okay, is basically decided by the size of the base circle. If the base circle becomes smaller, the involute becomes more curved, as I demonstrated over here. If the base circle becomes larger, then the involute becomes less curved. When the base circle becomes infinitely large, then involute becomes a straight line. So straight line is a particular type of the involute profile. Thank you.